Hello, and welcome to this presentation, Understanding Power Supplies, Series and Parallel Operation. In this short presentation, we'll explain how multiple power supply channels can be connected in series or in parallel in order to increase their maximum output voltage or current. Many DC benchtop power supplies have multiple channels, and in most cases, these channels are used independently to provide power to separate devices or loads. That said, it's often possible to combine the outputs of multiple power supply channels. Combining channels can be used to increase the output voltage or current beyond that which can be provided by a single channel. The only requirements for combining channels in this way is that the channels must be floating and galvanically isolated. Floating means that the channels are not connected to the common instrument ground, and isolated simply means the channels are independent of each other, with no current flow between them. There are two ways power supply channels can be combined. If the channels are connected in series, this enables higher voltages. On the other hand, if the channels are connected in parallel, this enables higher currents. These connections are typically made externally, although in some cases, these connections may also be made within the supply itself. Let's start by looking at series operation, which combines channels in order to produce higher voltages than would be possible with a single channel. We'll start by configuring each of our 4 channels to output 25 volts, and then connect them in series. The result is a combined output voltage of 100 volts. Note that the channels don't all have to be the same voltage. We could also use this combination of different voltage settings to obtain the same 100 volts combined output. When connecting channels in series to obtain higher voltages, it's important not to exceed the maximum voltage to ground rating of any channel. This maximum channel voltage is higher than the maximum output voltage, but is still limited. For example, here our power supply channel can produce up to 64 volts on a single channel, and has a maximum 250 volts to ground. If we connect the negative terminal to ground and configure maximum output voltage, there are 64 volts across the channel relative to ground. If the negative terminal of this channel were instead serially connected to a voltage source producing 36 volts, the channel now has 100 volts across it, which is still within the 250 volt limit. However, if the series-connected input voltage to this channel were increased to 200 volts, then the channel would have a total of 260 volts across it, exceeding the maximum voltage to ground of 250 volts, and potentially creating a damaging or dangerous situation. Now let's look at an example of parallel operation, which is used to produce higher currents. In this example, our channels are set to 2 volts, but each channel can source only up to 10 amps. Combining these channels in parallel means that we still have only 2 volts across the load, but the combined channels can now deliver up to 40 amps through the load. Let's end with a brief summary. Every power supply channel has a maximum output voltage and current. If we need higher voltages or higher currents, one solution is to combine multiple power supply channels. By combining channels in series, we can increase the maximum achievable output voltage. And by combining channels in parallel, the maximum output current can be increased. And remember that in the case of series connections, it's important not to exceed the maximum voltage to ground rating for each channel. This concludes our presentation, Understanding Power Supplies, Series and Parallel Operation. If you'd like to learn more about benchtop DC power supplies, please see the links in the video description. Thanks for watching.